Hello, my name is WONG TECH CHING and my metric number is MA18167. Today I will present about the study of the development of propulsion system and control system of the electric go-kart. For the abstract, the acceleration and torque of the electric go-kart are more effective than internal combustion engine. However, most of the electric go-kart which operate on electric motor, DC motor, are often expensive due to its DC motor. Therefore, this study is to develop the alternator to DC motor by wiring it a connection to star connection. The importance of this study is to develop the low cost of the go-kart that friendly to environment. It is hoped that the development of this electric go-kart using the alternator as its DC motor can help to reduce the cost of development of the electric go-kart. This is the comparison between the internal combustion engine, ICE, and the electric motor. There are 5 criteria that we choose to compare between ICE and the electric motor. First is in terms of speed, cost, environmental friendly, weight, and the maintenance. For the electric go-kart, it much more better compared with the ICE in terms of speed, environmental friendly, and the maintenance. In terms of speed, environmental friendly, and maintenance, electric motor much more better compared with the ICE. However, for this study, we choose the alternator as our DC motor to help reduce the cost of development of the electric go-kart. For the problem statement for this study, ICE powered go-kart carry higher risk to the driver. For example, flammable fuel that may cause the explosion, noisy, and not environmental friendly because the carbon emission. And second is the current DC motor require a lot of maintenance and very expensive. Hence, we use the alternator to make a DC motor. There are 2 main objectives for this study. First is to convert the powertrain system of the electric go-kart to the electrical motor. And second is to develop the propulsion system with alternator as a DC motor and control system of the electric go-kart. The scope for our project is first is to change the current ICE go-kart engine to electrical motor by using the car alternator. And second is we focus in to build the electric go-kart that are suitable for recreational and fun ride. The literature review for this study is we have done some research and refer with other papers that has been done by others researchers for the electric go-kart. Powertrain is referred to the set of components that generate and deliver the power, and it's a simpler system and has a 60% fewer components than ICE go-kart. There are 5 main components of the electric go-kart powertrain. First is a battery pack. Second is a DC and AC converter. Third is electric motor. Fourth is onboard charger. And last but not least is a thermal management system. Drivetrain is referred to the group of components in a vehicle that provide power and the wheels. The electric motor eliminates the needs of a motor to stay idle. It also reproduces the consistent amount of torque at any given RPM, and it delivers power instantly. For the battery, it must be commercially availability and cost, static and dynamic, electrical properties, and constant current discharge rate. By refer to the Brigade and Alocon 2017, it states that for the suitable battery for the electric go-kart is between 40 to 60 ampere per hour. Electronic speed controller or ESC control the voltage and current supply to the brushless DC motor, our converted alternator. It converts the direct current supply by battery into 3-phase AC to alternator. It also consists of 3 key components, which is a BEC or voltage regulator, processor, switching by MOSFET. Next is the methodology of this study. First is we research and market survey for the suitable part of the go-kart, and we design the electric go-kart and we do some simulation analysis with the computer software. If the design of the electric go-kart suitable to be used, and we will proceed to buy and build the part of the alternator, and After that, we fabricate the electric go-kart and analyze the performance of the complete electric go-kart. Then we proceed with the design criteria for this study. We have designed 3 models of the electric go-kart for this study. First is design A, design B, and design C. The difference between design A and design B is in terms of battery. For the design A, we use a 48 acid-based battery. However, for the design B, we use a 48-volt lithium-ion battery. The difference also in design A and design B is in terms of a throttle. The design A, we use a cable throttle, and however, in design B, we use a drive-by-wire throttle. And the difference between design B and design C is in terms of the DC motor. For the design B, we use a DC motor to drive the go-kart. However, for the design C, we use the alternator that has been converted to the star connection to drive the electric go-kart. The second difference between design B and design C in terms of wiring between the battery and the speed controller. In order to choose the better design for design A or design B or design C, we use 8 criteria to compare between design A and design B, which is first is speed, weight, capacity, wiring, compatibility, cost, complexity, and balance. And based on the analysis that we have been done, the design C is the most suitable for our study because it has highest net score compared with design A and design B. The reason that we choose the design C because design C we use the lithium-ion battery. Because of lithium-ion battery is better performance than lead acid. It faster charging and lightweight and save more space. In terms of a motor, design C use the alternator instead of a DC motor. The alternator is cheaper compared to the brushless DC motor and easy to find in the market. By wiring it to star connection, we can convert the alternator to DC motor. Next is a sprocket design for our alternator. This is a design for our driver sprocket. It has a 75 millimeter diameter, and the thickness of the sprocket for our study is 7.5 millimeter. In order to convert the alternator to the DC motor, we need to do some wiring and a modification for the alternator. First is we need to remove the rectifier at the alternator since the rectifier will be not used for this study. Second is we need to convert the wiring to the star connection as it's stated in the figure on the slide. This is a schematic diagram for our study between the battery and the speed controller and our motor. The 48 volt used to supply the current to the system, and 12 volt will be connected to the rotor through the brush, and this will create the electromagnet inside the alternator. The throttle and speed gear used to control the speed of the alternator. So this is the Gantt chart for our project, which is red is represent the planning, and the blue is represent the actual activity for our project. For the first week, we're briefing with the coordinator about the data and the scope for our project. And for the second to 14 weeks, we do some group discussion, brainstorming, and discuss about our project. In the week 2, week 6, week 9, and week 14, we briefing with a coordinator and present the progress of the project. And we spend 2 weeks in week 2 and week 6 to completing the report in chapter 1 and chapter 2. And we do some midterm presentation in the week 7. After that, we survey the material and the part needed for this project. Actually, we're planning in week 7 and week 8. However, because of the pandemic, we spend 4 weeks, which is in week 7, week 8, week 9, and week 11 to survey and purchase the part that will be needed for this project. And we continue writing the report for the chapter 3 in week 8, 13, and revise the report with the supervisor in week 13, and a final presentation in week 14. That's all the presentation for the development of the propulsion system and control system of the electric go-kart, and thank you.